Hey guys, I just wanted to drop a quick video. I just had this kind of like thought or epiphany on programming problems in general, especially when it comes to terms of coding interview problems. So I think a big chunk of the work is actually being able to just properly categorize your problem. And don't worry, I'm going to include this link in the YouTube description. So actually, let me just copy that for later. But essentially, any type of coding interview problem, especially with a time limit, you're going to be usually answering a couple or one within 30, 45 minutes. Um, you're not going to get anything too crazy unless you're a little bit more higher level or farther along your career path. But you have general categories in which you can answer these questions. So they'll have certain data structures, they'll have certain constraints, and then from that, that information that you kind of can gather either by asking the interviewer or looking at the code at the description, you can like further categorize that into specific potential solutions and specific categories. So, for example, your data structures, arrays, maps, linked lists, queues, heaps, stacks, trees, and graphs. Um, and then you have like your common algorithms here. But for example, like this is a great resource. Like so, for example, if your array is sorted, you have binary search two pointers as potential patterns. I know if you're like looking within two heaps, obviously, like trying to find the smaller and larger number of two arrays, heaps are great for that. For arrays as well and linked lists. The hare and tortoise algorithm is pretty cool. So that's a variation of the two pointers strategy. Backtracking is great for subsets and permutations. If you have a problem like where you're trying to merge time slots or merge intervals, there are specific merging techniques you could use. If you see a tree graph, immediately think either depth first search or breadth first search. So in terms of the shortest path, I always think breadth first search, but it does use a little bit more memory. For depth first search, you can easily do that in recursion. Just really recursive. It's easier to think about for breadth first search. But if you want to do that iteratively, then use a stack for DFS. Uses less memory. It goes all the way further down. So those types of problems, let's see, say like you're working with a binary search tree and they want you to find the path with a certain total, then depth first search would be a great technique to use. Linked list, two pointers. If you can't use recursion, then stacks for DFS, or you can use queues. For example, let's say you're looking at the number of island problems. A great way to like check different paths is just to use either DFS or BFS. This is like a key thing for me. Whenever you see the word max or minimum, I'm thinking, hey, that's an optimization problem, which is a dynamic programming problem. This is another good one, top least k items, and ask for common strings. So like you would either use a map or try. So map, you can use like a counter of like the different letters, and for try, just think about like if you're like looking to see if a certain word exists like in a dictionary, that'd be a great use case for that. Yeah, so these are kind of just general like categories. There's obviously more techniques that you can learn. Like I was saying, there's subset patterns, there's merge intervals problems. Um, let's see, two pointers is very helpful for a lot of array range problems as well. And my epiphany was basically like thinking about like the coffee taster's wheel. So when you're tasting coffee, you choose generally generic categories and then you go deeper and like make them more fine tuned. So kind of how like this leak code patterns has like different general categories. You might think about potential solutions. So maybe you have like um, a big area right here, fruity, so that might be like array problems, and then within that you have potential solutions. So with these leak code patterns, essentially all you're trying to do is like gather more data, refine it, and then like narrow down your potential solutions to a generic category. So if you have tree graph, you're like, oh, okay, obviously potential solutions might be DFS, BFS, Maybe it's a different type of graph problem, and you have to refine it more. And it's strongly connected components, so I need to look at after that a little bit further. But yeah, I just thought this wheel was perfect for actually trying to categorize like specific taste in coffee. And I was just thinking that it kind of was similar to how we try to identify problems when we're in coding interviews. For example, like stack problems, like you might have to do certain patterns with strings. That's a great use case for stacks. So that'd be a potential solution that's kind of popping in my brain. Like when I see like something like let's see the directory path problem. I think it's like problem number 71 or 73 on LeetCode, where you're basically the problem statement is like you have like this path, like a folder path, let's say like forward slash foo forward slash bar, and then you have like the command like cd dot dot forward slash baz, then that would basically like pop the last element of the starting path, and then you change into the second path. And how do you do that? Use a stack, or you can use just some clever iteration of the array. But that type of string processing problem is also useful for stacks. So again, like you have these generic categories, and then you can like really dig deep into these categories for specific solutions. So yeah, I hope this helps, and I hope you guys have a great Friday. Cheers.